Maxwell solved this problem. So what he invented in what is the inconsistency of Ampere's law? What he invented is plate 1 has more amount of charges and plate 2 has less number of charges. Because of this charge difference or potential difference, there is a change in electric field. So that is what he identified. Okay, a change in electric field induces magnetic field. Okay, so this is what the invention from Maxwell's equation or Maxwell. So first plate has more number of charges, second plate has less number of charges. Total charge difference takes place, so that the electric field intensity continuously varies. So this change in electric field is creating the magnetic field, inducing the magnetic field. Okay, so that is what the reason. So now in between the capacitor, I am talking about the in between the capacitor where the electric medium is available, where current I equal to 0. Okay, previously what is the equation? Ampere's law, B vector dot dl, that is equal to mu I, where I tends to 0, where B also tends to 0. So that is the previous statement. So now what the Maxwell did? There is a change of electric field is happening because of charge difference. So there is a flux lines or magnetic flux is generated due to electric flux, change in electric flux. So this is the reason. Rate of change of magnetic flux is generated, and that creates magnetic field. So this equation cannot be 0 within the capacitor also. Okay, so this is called ID. We are calling this is ID. That is called displacement current. So until that, now we discuss the conduction current alone, where the current is taking place only in the metallic medium. But when you are taking the displacement, that is a dielectric medium, there is also a charge possibility, current flow, that we are calling as a dielectric current flow or displacement current. Okay, so this is a Maxwell's equation, the revision of Ampere's law. So we modified the Ampere's law into modified Ampere's law or Maxwell's Ampere's theorem. So surface integral B vector dot dl, that is equal to mu naught into I. This is due to conduction current or IC. We can call this is the conduction current. Thus mu naught epsilon d phi E by dt. This is due to displacement current IB. Okay, now we have two type of current flow: conduction current and displacement current. Okay, so this is the equation where we can get the conduction current and displacement current. How we are getting this? Okay, next. So finally, we come to all the four Maxwell's equation. So Gauss law for electrostatics, any charge available that creates electric field, and that is diverging in nature. Then magnetic law and Gauss law for magnetism, diverging of magnetic field is not possible, so 0. Only magnetic field only can curve, it cannot diverge. Then Faraday's law of induction, integral of E vector dot dl, that is equal to d phi by dt. Rate of change of magnetic flux can create electric field. Then Ampere's law, integral of B vector dot dl equal to mu naught into I. This is due to conduction current and both displacement current, both contributing magnetic field. Okay, not only conduction current, also displacement current, both are combinedly contributing to magnetic flux lines. Okay, then this is a slight modification to the existing Maxwell's equation. That means we are trying to find the Maxwell's equation in no charges or free spaces. So free space will be no charge where Q equal to 0. So there is no charges in a free space or vacuum. There is no possibility of charges. Only charges available in the conductor. So if you put Q equal to 0, this term will become 0 because Q equal to 0. So there is a modification. Then B dot dA, this equation we can take as it is. Then here Faraday's law also we are taking as it is. And there is no charges at all. There is no conduction current at all. So these terms also tends to 0. So we will have only this particular term that we have written in this form. Okay. So while we are deriving all these vacuum and things, our electromagnetic signal is going to propagate in free space. Where free space or air medium. Where air medium, there is no possibility of charges. Okay, there is no charges, there is no conduction current. So without charge and without conduction current, we have taken all the Maxwell's equation, which we are going to apply for deriving electromagnetic wave equation or existence of electromagnetic wave equation. So this is the final statement. So integral of E dot dA equal to 0 in free space. Integral of B dot dA also is 0. Then E dot dl equal to minus d phi by dt. Then B dot dl equal to mu naught epsilon d phi by E by dt. Okay. So by using all these four fundamental theorem, okay, so we can write the equivalent also. So what is this? Divergence of D equal to 0. Actually, what is the formula? Divergence of B equal to rho V. There is no charge in the free space, so this is the formula, differential form of the first one. Then divergence of B, it is equal to 0. Second theorem, there is no change. Then what is this one? Curl E equal to minus rho V by rho V, Faraday's law. What is this statement? Curl Dutch, that is equal to rho D by rho V. Since it is a displacement current, so we can transform. So we can transform all these equations into differential form. Okay. So these are all the four fundamental equations, both in differential form and integral form. We will take into consideration for deriving Maxwell's equation. That's all about all the four Maxwell's equation. By using this, next class we will try to derive the electromagnetic